Hello everyone, my name is Akshay ESP, and today we will see how to turn on the 24 volts DC solenoid valve, which is from UFlow. Basically, we need a relay module which takes this is a relay module which takes 12 volts DC as input, and it can give an output of max output voltage of 30 volts DC or max 250 volts AC voltage, and this is in turn powered by this beautiful machine device named SMPS, which converts the incoming AC supply to 30 volts to a 24 volts regulated power DC supply, and the on and off will be controlled by this microcontroller named Arduino Duo, and this Duo receives power from a buck converter which supplies around 4 volts supply to it. Now I'm going to explain you guys the connection diagram before turning on the circuitry. Now this is a solenoid valve, and this is the relay module which takes 12 volts input and can control output of either 30 volts max DC or 250 volts max AC, and this is the supply SMPS. Now first thing is we have to connect the SMPS positive terminal 24 volts positive terminal, as this is relay is rated at 24 volts. We are taking 24 volts DC supply positive terminal to the NO pin, rightmost pin of the relay module, and then the negative is connected to the negative of the solenoid valve, and then the positive terminal of the solenoid will be given to the COM port of the relay. And this relay I have to for the working of the relay we have to supply a 12 volts DC, and this will be given by our buck converter, which takes 24 volts from SMPS and converts it into steps down it to into 12 volts DC output. Now when the supply was given, the current used to flow like this, and when the power is removed, the current will dip like this, and this time is very little. Okay, this time is very little. Now this can be better understood using an Ohm's law. We know the Ohm's law for normal resistive circuits. V is equal to IR. Now for inductive circuits, V is equal to L di by dt. So this is the change in current by change in time. The voltage through voltage across inductor is given by this equation. Now if you see here, the difference in the time is very less. The change in time. This can be written as I final minus I initial by T finals minus T initial. The final value of the current will be 0 minus the initial value will be suppose some x value. By the time given, the current will be negative, so there will be a reverse negative voltage spikes, that too in a very short time. That's the reason there will be an electric arc in the relay, the solenoid valve circuit if you don't connect any diode here. That's the reason, and it is not it's actually harmful for the internal circuitry of the relay module. So that's the reason you connect a diode in such a way that its polarity is opposite to the solenoid polarities. When the current flows like this, it doesn't flow here because it's reverse biased. It normally flows like this, but when the supply is turned off, only this circuit remains. So the discharging happens like this. Since it's a negative current, it will form a loop around this diode. Now I've turned on the main supply and the SMPS is turned on, and you can see the buck lights. Now this is supplying a required amount of voltage to the Arduino Duo, so it's turned on. Now the on and off of this solenoid valve will be indicated by click sound. If you hear a slow click, it means the solenoid valve is off. If you hear a high click, then the solenoid valve is on. Now I'm going to give this to the relay 1. The program says that if the trigger is on, then the solenoid valve will be on. You will know that by hearing a loud click. It turned on, and the relay is also on, indicating the light indicates that if the trigger pulse is low, you'll hear a low click sound, as you heard right now. I'm going to turn it on again. That's a loud click, and now a small click. So that's how you work on relay, and you can automatically control it, the on and off.